Calculus Chapter 2, Section 8, Implicit Differentiation and Related Rates. Okay, first of all, implicit differentiation is what we need to do when we have an equation where the x's and the y's, the two variables, the independent and the dependent, are kind of mixed up in the equation. We can't really get it to be y equals something or x equals something or whatever. It's just too difficult. We just can't do that. And that's where implicit differentiation comes into play. To differentiate implicitly, you're going to differentiate or take the derivative of both sides of the equation with respect to x, or whatever variable you're supposed to be taking the derivative with respect to. Then you'll use the rules of differentiation. Use the power rule when necessary, the product, the quotient, and the chain rules, whatever you need. Anytime an expression involving y or involving a variable other than the one on the bottom, like if we're doing dy dx, if you're taking the derivative that has anything but an x in it, then you have to write dy dx after that. You'll see how that works. You're going to isolate all the terms with dy dx on one side, factor it out, divide both sides of the equation to get the dy dx by itself. You'll kind of see that it's easier to show you than to explain it this way. So hopefully as we go through this, you'll get a little better handle on what we're doing. And in class, I'll show you obviously how this is going to work. Okay, so we're going to do y cubed plus x squared y to the fifth minus x to the fourth equals 27. Now this would not be one that you would want to try to solve for y. So we're going to use implicit differentiation, and we're going to find the slope of the tangent line once we've done that to the curve at the point 0,3. Now remember, the derivative is the slope of the tangent line. So what you're going to do is you're going to follow all the rules that we have, but anytime you take a derivative where a y is involved, you're going to write after that derivative dy dx. If you want to go ahead and give it a try on your own, go for it, pause the recording. If not, hold on and we will go through it step by step, and then you could try it on your own on some later problems. Okay, I know this is a lot all at once here, but look what we did. We're taking the derivative of both sides. Now, the derivative of y cubed is going to be 3y squared dy dx. Why dy dx? Because we didn't, because it was a y instead of an x. Anytime you take a derivative and it has a variable other than the one indicated on the bottom of that derivative ratio there, you must put dy dx. So 3y squared dy dx. Now, what we have to do for x squared y to the fifth is use the product rule. So it's x squared, it's the first, times the derivative of the second, which is going to be 5y to the fourth, but then that had a y. So dy dx plus, and now do the second times the derivative of the first, y to the fifth times 2x. And then the x to the fourth is just going to be minus 4x to the third. And the derivative of 27 of a constant is 0. Okay, now what we're going to do is we're going to move everything that doesn't have a dy dx attached to it to the right. So that's why in the next one we have the 4x to the third minus 2xy to the fifth on the right. And we're going to gather everything together that has the dy dx and factor out the dy dx. So we have dy dx times 3y squared plus 5x squared y to the fourth. Notice those were the two terms that had the dy dx. And then finally you divide so that dy dx is by itself. So there's the derivative. Now that was the hard part. The next part's going to be easy because all you need to do is put in 0 for x and 3 for y to get the slope of the line tangent to the curve. So we put them all in, and we get 0 over 27, which is 0. So the slope is 0 at that point, which means it's going to be for a minute. Okay, so what we're going to do here is you're going to try it on your own now. So pause the recording and see if you can do the derivative. Resume to check your answer. Okay, so derivative of both sides. Notice we have to use the product rule. So we have here the derivative of the first times the second, so it's 2y times x. But since we took the derivative of y, we have to put dy dx, and then plus the first times the derivative of the second, so that's going to be y squared times 1. Now moving on to the 2x to the third y to the third, we have to do the same thing. So we're going to do the first, which is 2x to the third, times the derivative of the second, which is going to be 3. So 2 times 3 is 6, y squared dy dx, and then reverse that, plus the derivative of the first, which is going to be the 6 x squared times the second, which will be y to the third, equals, and the derivative of 1y is just 1, but you got to put dy dx on there. All right, now we're going to move everything with the dy dx onto the right-hand side. You can do right or left, it doesn't matter. And they moved everything without a dy dx onto the left-hand side here. And then you factor out the dy dx, and the hard part's basically done because now we just divide. And that's your answer. All right, so now we have a demand equation. X equals the square root of 200 minus p to the third. And I think p there is the price. They've kind of mixed up the variables on us, but that's okay. We're going to find dp dx. Now notice the x is on the bottom. So when we take the derivative of x, that's fine. When we take the derivative of the p to the third, it's going to have to be, we're going to have to tack a dp over dx on there. So pause the recording, give it a try, and resume to check your answer. Okay, so d dx of x equals d dx of square root of 200 minus p to the third. The derivative of x is just going to be 1. Oh, before we do anything, they changed the square root to a 1/2 power. So the derivative of x is 1. Now we're going to have to use the chain rule. So it's going to come down 1/2 times 200 minus p to the third to the negative 1/2. Now the derivative of the inside times negative 3p squared dp dx, because the p is not what's in the bottom, it's an x, so anytime you're not doing what's in the bottom there, you have to tack that on. Okay, so then the next thing they did was they cleaned it up a little bit, and then finally basically multiply both sides by the denominator, divide by the numerator, and we get the final answer. A restaurant supplier that services the restaurants in a circular area in such a way that the radius r is increasing at the rate of 2 miles per year. So that's the rate of increase of the radius with respect to time. At the moment when the radius is 5 miles, at that moment, how fast is the area increasing? So what we're going to do is we're going to take our area for a circle formula, area equals pi r squared, and you're going to take the derivative of area with respect to time. So you want to find the derivative of area with respect to time. Okay, so pause the recording, give this a try, and resume to check your answer. Okay, so we take area equals pi r squared, and we want to find dA dt. Our derivative is 2 pi r dr dt. Again, notice we got that dt on the bottom there. The rate of change of the area, so we're going to put in the radius at the moment, which is 5 miles, and we're going to put in the rate of change of the radius at the moment, which is 2. So 2 pi times 5 times 2, and it's 63 square miles per year. Balloon deflating, losing 20 cubic centimeters of air per minute. At the moment when the radius of the balloon is 8 centimeters, how fast is the radius decreasing? The volume of a sphere is 4/3 pi r cubed. You're going to take the derivative of that with respect to time. Pause the recording, give this a try, and resume to check your answer. Okay, so we have our formula. We take the derivative of both sides with respect to time. We have dv over dt equals 4 pi r squared dr dt. Again, notice we're taking a derivative with respect to a variable that's not even really in the problem itself. So we have to have that dt on there. The dVdt is negative 20. That's how fast it's losing volume. And we know that the radius at the moment is 8 centimeters. And so putting all that in and solving for drdt, we find that when the radius is 8 centimeters, it's decreasing at a rate of 0.025 centimeters per minute. Okay, for Luce Landscaping, the total revenue from the yard maintenance of X homes is given by R of X equals 1,000X minus X squared, and cost is C of X equals 3,000 plus 20X. Suppose they maintain 10 homes per day at the moment when the 400th customer is signed. At that moment, find the rate of change of total revenue, total cost, and total profit. Again, we're going to be taking derivatives with respect to time. Pause the recording, give this a try. Try and resume to check your answer. Okay, so the derivative of revenue with respect to time is 1,000 times dx dt minus 2x times dx dt. And then putting in the numbers that we have, dx dt is 10 and x is 400, so we have that the revenue is changing $2,000 per day. Cost, you see here the derivative of cost with respect to time. And again, putting in 10 for dx dt, we get 200 per day for the cost. For the rate of change of the total, subtract the two, and for profit, we get $1,800 per day. Okay, here's our section summary. Pause and look over this, and then resume to do some additional problems. Okay, try these problems, pause as you do them, and resume to check your answer. Continue this way to the end of the recording.